So that's what we do is, okay, this again reef idea, it's a reef problem. So now this can be written as minus dou by dou V of, okay, pick up. What, how do you write average energy? Summation over, can I write NS mean into ES? I mean, I'll take a summation, even if you take integration, okay, but I'll take a summation which is this summation only converted into integration because energy levels are closely spaced. I'll take summation, which is more better actually. Now look at here, this NS mean, that is the average number of particles. That doesn't depend on actually volume, okay. This single particle energy levels, those depends on volume actually, okay. That's why this goes inside. So average pressure of the quantum gas, that's equal to minus summation over or summation over, okay, yes, NS mean, okay, into minus dou ES by, okay, dou V, okay. Pick up the single particle energy level that depends on confinement region actually. Speak up. That's why this derivative exists. Now what I'm going to do here is I'm going to write it as summation over, okay, yes. So NS mean into PS. I'll define it as a PS, okay? It's not any measurable physical quantity. I'm going to say PS is equal to minus dou ES by dou capital V, okay? V is the volume of the container, okay? Just this is similar to this one, okay? I'll say this is, okay, speak up, pressure contribution of a single particle in the state S. I'll say like this. I mean, you don't measure pressure due to single particle. You are measuring total pressure only, okay? But I'm going to write this one. I'm going to name this one, okay? This parameter, okay? Pressure contribution of a single particle. I mean, when you see this expression, it looks so. Each of the, what you call, state contributing some pressure. These are the average number of particle, okay? And it is getting us new total pressure, okay? Speak up. Rough idea, pressure contribution of a single particle in the state, yes. In the state, yes. Is that okay? Speak up. Now, if you know this one, you can substitute here, you can find this one. What is this ES actually? Speak up. This is actually some constant into K power some factor. What is this K? Root of Kx square plus Ky square plus Kz square to the power something. To the power something. What is that Kx, Ky, Kz? Root of, do you remember, 2 pi nx by lx, okay, the whole square. We write ES because to make it simple, it's actually ES is nothing but, okay, we say S state, am I right? Pick up, single particle state. It's nothing but E nx ny nz. We are talking about nx ny nz only. Pick up. I mean, simply we write ES actually, single particle state and all. Single particle state is what should be specified by nx ny nz, isn't it? Because it's in the 3 dimension. So plus 2 pi by Ly into Ny the whole square, okay, plus 2 pi by Lz into Nz the whole square. Now what we do is, okay, power something. Power something, okay, speak up. Now we write Lx equal to Ly equal to Lz, okay, that we write in terms of volume. I mean, we take a cubical container, we write in terms of volume, then we take that volume outside, we take volume derivative. Pick up. That's the basic idea. So can I do that one? So let me take first photons. Okay, pick up. Now look at here. Now it all depends on dispersion relation. This relation, whatever we are deriving, it depends on dispersion relation. Okay, pick up for photon. Okay, photons. So what is the dispersion relation? E is equal to, so P into C, that's equal to H bar C into K. Okay, pick up. So that's a photon energy expression. Okay, pick up. So K is nothing but, pick up, root of Kx square plus ky square plus kz square. So that I'm going to write like this, okay? E nx ny nz, that's equal to, pick up, h bar c into what is k? Speak up, root of 2 pi nx by lx the whole square plus 2 pi ny by ly the whole square, okay, plus 2 pi nz by lz the whole square, isn't it? Now what I do is I'll write Lx is equal to Ly is equal to Lz is equal to volume power 1 by 3. What is volume? Lx equal into Ly into Lz. We have written volume, okay? I'll take Lx equal to Ly is equal to Lz is equal to L, okay? Pick up. Is equal to L here. I'll write L as, pick up, volume power 1 by 3. Why not? Speak up. Anyway, later we try to connect it to per unit volume. Size of the box doesn't matter then, isn't it? When you make it per unit volume, okay? Speak up. So that's why E nx ny nz, okay, that's equal to this L under root of L, no, L square under root, am I right? L, 1 by L will come outside. Speak up. 1 by L will come outside. Speak up. So h bar c divided by L, okay, speak up. So this whole thing is root of, so 2 pi nx square plus 2 pi ny square. I mean, after some practice, you can write still more direct step, okay, speak up. 2 pi nz square, okay, pick up. What is this L? I'm going to write it like this, okay, pick up. I prefer writing it like this. E, okay, nx ny nz, that's equal to some constant, okay, which is actually function of, it contain nx ny nz. I'm not caring about that one, okay, divided by what is L? V power 1 by 3. I'm going to treat it like this, energy expression like this, okay, because now my dou a pressure contribution to particle in S state, okay, because that's equal to minus dou Es by dou V, okay, that's nothing but minus dou E nx ny nz divided by dou V. What is that one? V power minus 1 by 3 C V power minus 1 by 3, pick up, that's equal to minus minus plus, okay, 1/3, okay, into constant depends on nx and y nz, okay, so V power minus 1 by 3 minus 1, am I right? Now what I do is, okay, speak up, I will keep it as it is, okay, so PS is equal to 1/3 of C of function of nx comma ny comma nz, okay, so I'll write V power minus 1 by 3, V power minus 1 I will take it in the denominator, V power minus 1 by 3 into V power minus 1, 1 by V I will keep it again. What is this one? This is again the energy. Speak up. This C into V power minus 1 by 3, that's again energy. Speak up. That's nothing but, okay, 1/3 1 by V into again E nx ny nz. Can I write like this? Or 1/3 1 by V times E, yes, total average pressure, there's nothing but we have written ns mean into, speak up, PS. What is that PS now? What is that PS now? Summation over S. Pick up. NS mean 1/3 of 1 by V times ES. So average pressure, that's equal to, speak up, 1 by 3V. What is this one? Summation over S. NS mean into ES. Is that okay? Speak up. Now what is this one? total average energy. P is equal to 1/3 of, pick up, E bar by V. Okay, I mean we find E bar only. Okay, for photon gas we find E bar only. So then somehow we are going to connect it to average energy. Sorry, average pressure. Okay. Radiation pressure you can call like, because we have taken photon here. Am I right? Pick up. That's 1/3 of energy density. Total energy density. We say like this. Okay. Now it all depends on. Don't forget. What does it depends on? Dispersion relation. Pick up. That dispersion relation led to this relation actually. Okay, so now somehow we can say pressure is related to energy density. Okay, how it is related to energy density, that depends on dispersion relation. Okay, because now what I do is, okay, I'll take quantum non-relativistic quantum gases. Okay, because non quantum gases. Okay, speak up. 3 dimension only. We define pressure for 3 dimension only. Okay, speak up. Don't worry about dimension. Okay, E is equal to h bar square k square by 2m. Speak up. Again the same thing. Okay, Es is nothing but E nx ny nz is nothing but h bar square by 2m into under root of kx square ky square 2 pi nx by lx square plus 2 pi ny by ly square plus 2 pi nz by lz square, the whole square. Now what will come outside? I mean, if Lx equal to Ly is equal to Lz is equal to L is equal to volume power 1 by 3. 1 by L square will come outside. Am I right? Es, that's equal to E nx ny nz. Okay. You will have h bar square by 2m. Okay. 1 by L square. That's nothing but V power 2 by 3 into under root of this one. I'm going to write it like this as earlier. Okay, h bar square by, or I mean 1 by V power 2 by 3 into C depends on nx, ny, nz. I'll write like this. Okay, pick up. So this is your Es or E nx, ny, nz. Okay, speak up. Now Ps is nothing but minus dou Es by dou V. Okay, when you do this one, minus plus 2 by 3. Am I right? 2/3 V power minus 2 by 3 minus 1 C nx ny nz. Okay. Ultimate idea is writing this one again in terms of this energy, so that when you substitute back, it will convert to that average energy expression. Okay. So 2/3 of, okay, 1 by volume V power minus 1 by volume C nx ny nz into V power 2 by 3. Is that okay? Speak up. V power 2 by 3. Speak up. So Ps is equal to 2/3 of, can I write Es by volume? This one, this is again Es. Okay. So then total average pressure, this is equal to summation over Ns mean into Ps. Actually, this has no physical meaning. Okay. Because just a term we defined. Okay. Because this is related to some single particle and all. Okay. Because not single particle energy level actually. Okay. So that's why. So that will become 2/3 of, okay, energy density. You can guess when you substitute. For non-relativistic particle, okay, average pressure, okay, speak up. That's equal to 2/3 of energy density. Okay, pick up. For relativistic particle like photon, okay, for photon usually average pressure is equal to 1/3 of energy density. Okay. Now you got pressure, you know energy density. You can do lot of thermodynamics related to photon. You can define entropy. I mean, there are some questions related to entropy of photon gas. Okay, we have to deal with one separate class on some thermodynamics related to photon. Okay, in Blundell and Blundell, one problem is there, A, B, C, D, like that. Okay, they even define equation of state for proton gas. What is that one? PV is equal to something into N kBT. This will be around 0.9 actually for proton gas. Speak up. So all of those, okay, I mean all of those requires, I hope this, you need to find this one. Okay, you need to find this average energy, Riemann-Zeta integral for proton, sorry, not for this one, for proton. You need to find this one, that Riemann-Zeta integral. Once you find this one, okay, once you take that part from statistical physics, and if you take this one, the rest of all we can do some thermodynamics over there. Okay, we shall do that one. I mean, they have asked even some isobaric, isochoric, this kind of thermodynamic process. Okay, for proton gas and all. Okay, very nicely designed question. Anyway, we shall handle. Okay, right now this is for average pressure related to energy density for non-relativistic particle. Okay, so this is for proton. Okay, in one CSIR-NET question, that is the question somebody asked in the Slack. Am I right? Because they have given E is equal to some constant into K cube. They asked, speak up, pressure as a function of energy density only. Speak up, check that out. So K cube. Now again try to write it in terms of like this. Okay, speak up. Try to grab that length term outside, write length in terms of volume, take volume derivative. Okay, learn this one. Dispersion relation is given. Speak up. Single particle energy levels of non-interacting three-dimensional isotopic system labeled by momentum P. Okay, E is equal to some constant into, speak up, K cube. Am I right? Speak up. He said three dimension. Okay. Obviously, he is asking pressure. Pressure you define in three dimension only. Okay. Speak up. So the ratio of P bar by E, average pressure to the energy density. Speak up. Average pressure to the energy density. Speak up. How do you start? How do you do? Speak up. E nx ny nz or K. What is K actually? Speak up. Root of kx square plus ky square plus kz square. These are quantized. Speak up. These are quantized. That's equal to root of, what is this one? 2 pi nx by lx square plus 2 pi ny by ly square. Pressure of ideal gas, quantum ideal gas I have done. Photon gas and classical, I mean non-relativistic gas and all. 2 pi nz by lz the whole square. Okay, I'll take lx is equal to ly is equal to lz is equal to l, that's equal to volume power 1 by 3. L cube is volume. Okay, volume power 1 by 3. So then that K is equal to, okay, so volume power 1 by 3 power, what will come out? Or I have K cube here. Am I right? Speak up. So then E, okay, nx, actually I have written ES actually. Do you remember? S is a state. Okay, speak up. So that's equal to C into K cube. That means, how do you write? Speak up. Raised to 3 by 2. Am I right? Speak up. So 2 pi nx by L, or I can write like this. Okay, 1 by root L square outside. Okay, I'll first write K. K is nothing but, okay, 1 by L into this root stuff. Okay, speak up. Now energy is equal to some constant into K cube 1 by L cube. Okay, into this root of this one, the whole cube. What is 1 by L cube? L cube is nothing but volume, isn't it? Speak up. So energy of the S state, that's equal to, okay, C into this constant. Okay, I mean this root of this stuff divided by volume. Am I right? Speak up. Then what we have written? Do you remember? Pressure contribution by the state S. That's equal to minus dou Es by dou V. Do you remember this one? So that's equal to, what we did is, so that's equal to C into this under root of this one, okay, whole cube actually, okay, whole cube. This will not contain volume. Volume term we have taken outside. Okay, speak up. What is this one? 1 by V minus 1 by V square. Am I right? Pick up minus minus plus 1 by V square, isn't it? Now this one, what we have written is PS is equal to, this is pressure contribution by the state actually, okay, speak up, not by the particle, by that energy level actually, okay, speak up, bit different story. Again we have written 1 by V times 1 by V into C into, okay, speak up. So root of this one whole cube divided by V again, am I right? What is this one? PS is equal to ES by V, isn't it? Then total pressure, isn't it? Total pressure, dou by dou V of, okay, average energy, am I right? Then I have started arguing that dou by dou V of this average energy can be written as summation over NS mean into ES. That NS mean we already know, that doesn't contain volume. This ES depends on volume. That's why this volume derivative we took inside. Isn't it? Can you recall? That's how we argued actually, okay? So now if this is like this, okay, this relation will also be like this only, okay? Speak up. Total pressure, that's nothing but summation over NS mean into PS. Summation over all state, that's nothing but summation over NS mean into ES by V, okay? Summation over S, that's nothing but 1 by V into average energy. What is E bar by V? That is the energy density. Okay, pressure is equal to energy density here. There is no other factor at all. Am I right? Speak up. That's what he is expecting. Pressure by energy density. That's one actually. Is that okay? Speak up. He has given dispersion relation. From dispersion relation, you should find this one. Okay, speak up. Again, the reef method only. Okay, whatever I have done, that's a reef method only. Okay, speak up.